Hello. Today's video is on why do we need special characters in our passwords? And do we need them? So let's pretend like we had a password that was just one digit and only could use the letters A, B, or C. With this setup, we only have three possible passwords, and that's just A, B, and C. If we expand that and allow 2 digits to the password, now we have 9 possible passwords, as shown on the screen. And taking it to 3 digits, it brings it up to 27 passwords. So we can see from this that the more we increase the length of our password, the more possible passwords there are. And this matters because if a hacker is trying to break into one of your accounts or decrypt a file or something like that, if they don't have any clues to go on, they will only be able to brute force the password. And that's kind of the ideal. And we want to make that as large as possible, however many passwords that they have to brute force. So making the password longer increases the number of passwords, but so does increasing the number of characters in your alphabet that are allowed in your password. And so here we can see with a single digit of just using a number 0 through 9, we have 10 possible passwords, and here they are on the screen. And at 2 digits, we have 100 possible passwords, just like this, shown here. And at 3 digits, it takes it up to 1,000. And so in general, if you have, if A is the size of the alphabet of your password, and B is how many digits you use, the number of possible passwords is A raised to the B power. And so here we can see this table. It shows some possible numbers of digits for these different password schemes. And the graph on the right shows a stark difference, right? When you only have 3 letters, it's completely dwarfed by having 10 letters or characters allowed in your password. But we can go further, of course, right? So if we just use lowercase letters, there's 26 of them. And so our password, by the time we have 5 digits, it already gets up to 12 million different possible passwords. And so that dwarfs just using the numbers 0 through 9. And we can augment that further by saying that it can be either a lowercase letter or a number. And then once again, it dwarfs the last option. It's at 60.5 million possible passwords by the time you hit 5 digits instead of almost 12 million. But now if we allow both lowercase letters, numbers, uppercase letters, and special characters, that brings our alphabet size up to 94 possible symbols. And once again, by the time you get to a 5-digit password, it completely dwarfs the previous thing. And we're at 7.3 billion possible passwords, which is pretty nice. So some conclusions so far is we've seen that bigger A's, which is the size of the alphabet, dwarfs smaller A's, even at 5-digit passwords, which is pretty small by today's standards. But just because a password allows you to enter these characters doesn't mean that we actually do. And so if it allows all these things, but you're only using lowercase letters, and a hacker assumes that you are, or has knowledge that you might be doing that, then it effectively shrinks the space that they have to brute force and makes it easier for them to guess your password. And so this is why the recommendations are to use uppercase letters, lowercase letters, numbers, and special characters, because it forces the maximum sized alphabet. But we've sort of hit a problem, and that we've run out of alphabet. And that's, unless we start using unicoded emojis, but that's going to get pretty messy. And so all that we have left is just to increase B, how many digits you use in your password. But doing this is kind of a mess, right? So here we've randomly generated 20 digits of special characters. And in this setup where it's a 20-character password using special characters, it's 2.9 times 10 to the 39th number of passwords possible, which is a pretty big number. However, there's a thing called passphrases. And what it is here we've randomly generated a passphrase, and it's 30 digits of just lowercase letters. But the phrase is pretty easy to remember. It's rambling, pedicure, clutter, swell, right? Anyone can remember that. It's a lot easier to remember than the special character randomized password. And so when we do that, we have 30 digits there. It's 2.8 times 10 to the 42nd total number of passwords, which, believe it or not, it's 1,000 times better. And we're just using lowercase letters, which is pretty crazy. However, maybe this is time to bring back leetspeak for those of you that remember that. So if we take a passphrase, like I said, we have 2.8 times 10 to the 42 possible passwords. But now, when we do uppercase and lowercase and numbers and special symbols to make it leetspeak, we actually have 1.5 times 10 to the 59 possible passwords. And what is that? That's 100 quadrillion times better. So yeah, let's bring back that leetspeak.